I am K. Balaya, Assistant Professor of Chemistry. Today I am going to discuss estimation of HCl by conductometry. Estimation of HCl by conductometry. This experiment is also known as conductometric titration of strong acid versus strong base. So, our experiment aim is estimation of HCl by conductometry. What is mean by conductometry? The conductometry means with the help of conductance values, determine the end point of acid base titrations. This is known as conductometry. So, in this experiment, we required some operators. We required the following operators. One is conductivity meter and conductivity cell and burette, pipette, beaker and glass rod. These are the required operators. Next, in this experiment, we need some chemicals. We required some chemicals. Those chemicals are NaOH and HCl. NaOH concentration is 0.1 normal. Means it is a known concentrated solution. That's why it is called standard NaOH. Here HCl is unknown concentrated solution. In this experiment, you have to find this concentration, HCl concentration. That is our aim of this experiment. Next, principle. Now I am going to discuss principle. The principle here I given the equation. I wrote the equation H plus NaOH is giving rise to NaCl plus water. So, in this experiment, what will happen? First of all, you take HCl solution in a beaker, and NaOH you fill in the burette. That NaOH you should add to the HCl solution. Conductance is decreases. The conductance value is slowly decreases. So, because of highly mobile H plus ions, high concentrated or high mobility of H plus ions is replaced by OH minus ions. That's why the conductance is gradually decrease. That's why initially the conductance value is decreases every addition of NaOH. After that, slowly the conductance is increases because of fast moving OH minus ions are increases in a given solution. That's why again its conductance starts to increase. So then you plot the graph against the conductance versus volume of NaOH, we will get this type of model graph. I already explained the principles. Here is initially the HCl conductance is high. Because of HCl is a strong electrolyte, it have the more number of H plus ions. That's why HCl have a more conductance. Every addition of NaOH, the conductance is slowly decreases or gradually decreases. Why? Because the H plus ions are replaced by OH minus ions. That reaction is going to neutralization point side. That's why the number of H plus ions are decreases in a given solution. That's why here this type of equation is occurred. H plus NaOH is giving rise to Na plus and water is formed. That is happens. After end point, the slowly conductance is decreases. Because of free OH minus ions are increases in a given solution. That's why again its conductance starts to increase. Finally, these two lines are intersect at this point. These these two lines will give the end point. Okay, this is called a end point or neutralization point. This is about principle of the experiment. Principle of the experiment. Next, now I am going to discuss procedure. Procedure. This is the procedure table, observation table. This table is divided into three parts. One is serial number, the volume of NaOH and conductance. Okay, here first in procedure, first we take the conductivity meter. This is the conductivity meter, and this conductivity meter already I connected conductivity cell. This is the conductivity cell. These are the two is the very important. Okay, next this conductivity meter and conductivity cell. This conductivity cell is connected to the conductivity meter. This conductivity cell is dipped into the given solution. Okay, what solution is taken in a beaker? HCl is taken in a beaker. Okay, after taken HCl, this conductivity cell is dipped into the HCl solution and measure the initial conductance of the HCl solution and measure the initial conductance of the HCl solution. Then you note the initial conductance of the initial conductance of the value in a table, and you add NaOH solution from the burette. We add 1 ml of NaOH solution from the burette. Okay, first you take the burette and fill the NaOH solution in a beaker. Then you add 1 ml of NaOH solution into the HCl solution and stir the solution with help of glass rod and conductance value is decreases according to principle. Because of the H plus ions are replaced by OH minus ions. Okay, H plus ions is replaced by OH minus ions. That's why its conductance is decreased. Okay, so that's why the conductance value is decreased. Again, you observe that conductance value is given this conductivity meter, and that conductance value is noted in a given table. This same procedure will repeat the up to 20 readings and 30 readings. Will repeat the 20 to 30 readings. Okay, this is our experiment procedure. Once again, I will reveal very short. Okay, first you take 20 ml of HCl solution in a beaker and dip the conductivity cell in a HCl solution and add 1 ml of NaOH from the burette. Okay, then you stir the solution and measure the conductance value. This procedure repeat the up to 20 to 30 reading. This is the brief explanation of conductometric titrations. Then after taking conductance values, you plot the graph. Okay, versus volume of NaOH versus conductance. Volume of NaOH will take on x-axis, the conductance value take on y-axis. You plot the graph, you will get this type of model graph. Okay, so according to values, we will get this type of graph. Then we will find out the end point. These two vertical lines intersect a particular point. That point will give the end point. That is called a end point. Okay, we will take the end point from the graph and we calculate the normality of HCl solution. I given the formula here. The formula is N1 V1 equal to N2 V2, where N1 is normality of NaOH. Already we know that is 0.1 normal, where V1 is volume of NaOH. This is the end point. This value will take from the graph. Next, N2 is the normality of HCl. It is unknown. We will find out. Okay. Then V2 is the volume of HCl. Already we know 20 ml is taken in a beaker. Okay. So this is about the formula description N1 V1 N2 V2. Okay. Then from this equation okay, we'll get this formula N2 equal to N1 V1 by V2. Okay. Here already we know N1, that is 0.1. Okay. Here V1 you will takes from graph, taken from graph. Next V2 is volume of HCl, already we know 20 ml. Okay. These all values will substitute in this equation. Finally we will get the N2, normality of HCl. After calculating normality of HCl, we will find out the amount of HCl, HCl. How to find out amount of HCl? By taking this formula N2. Here N2 means normality of HCl. Normality of HCl into 36.5. 36.5 is the molecular weight of HCl. 36.5 means molecular weight of HCl. We will get the amount of HCl. Amount of HCl. This is our calculation part, overall calculation part. After calculating amount of HCl, we will write the results. You have two results. One is normality of HCl, okay, then amount of HCl, amount of HCl. Our experiment aim is, this is to calculate the normality of HCl and find out the amount of HCl. This is our overall experiment about calculation, graphs and procedure. Thank you.